All right, so let's look at this one. So since your null has one mean equal to another mean, it means the difference between the two is 0. So let's keep that in mind as we get ready to do the test statistic. Here's our n sub 1. Here's our x bar sub 1. Here's our standard deviation sub 1, our s sub 1. And then here's our n sub 2, our x bar sub 2, and our standard deviation s sub 2. All right, and I've written those down so I don't have to keep going back to this screen. All right, but I brought up in the background, there's the formula we're going to use for two large samples. So we'll use this formula, and our D0 here will be 0, since our two means were equal to one another in the null hypothesis. All right, so what we need to do is subtract our two sample means on top, and on the bottom we'll have the square root of each of our standard deviation squared divided by their sample size. All right, so let's actually do this on a separate sheet. All right, so we're going to have C equals, on top we will have our first mean, which was 2.42, minus our second mean, 2.37, divided by, on the bottom, we'll have the square root, and we will have the first standard deviation, which was 0.06, squared. Let's see if I can get that square in there. Divided by the sample size, plus the second standard deviation, which was 0.08, squared, and divided by its sample size was 50. And now we have to work this out. So let's do the top subtraction first. So when I subtract the top, I'll get 0.05, and I will do the inside of this square root first, which will give me 0.000230.857. I want to take that pretty far. All right, and now I'll do the square root of that. Now, if you have a graphing calculator, you can do all of the bottom at once. And I get 0.01519398. And then my last step, of course, is to divide those out. And I get 3.291. All right, so there's my test statistic. Now let's get the critical value. Go back here for a second. Where is it? All right, so our critical value. All right, now this is a right-tailed test, and we have an alpha significance level of 0.05. So since it's right-tailed, we must subtract that from 1. 1 minus 0.05 is going to be 0.95, and I think I have Excel open, so let's do equal norm.s.inv 0.95, and our critical value ends up being 1.645, depending on how many decimal, two decimal places, so 1.64. And hopefully that will help.